So for this video, right, we're looking at the Regents Review short answer part 3 questions. First one is a stats question, right? 2-point question. It says, giving you all this information, right? Grocery store orders 50 bags of oranges from a company's distribution center. The bags have a mean weight of 3.85 pounds per bag. The company claims that their bags of oranges have a mean weight of 4 pounds. The grocery store ran a simulation of 50 bags 2,500 times, assuming a mean of 4 pounds, and these are the results. The question is asking you, right, is the mean weight of the grocery store sample unusual? Explain using the results of the simulation. All right, so first, right, I look at the simulation, right? It looks like a normal distribution, so that means, right, they're giving me all this info, but all I really have to do is look at two things, right? I'm looking at over here, right, the mean and the standard deviation of the simulation. And then I'm looking at the mean weight over here, right, that the grocery store actually found that their oranges had, right, which was 3.85 pounds. If I want to see if something's unusual, right, I'm looking for my 95% confidence interval, which is 2 standard deviations off of the mean. So in order to do that, right, I'm taking my mean, and for my minimum, I will be subtracting, right, minus 2 times my standard deviation, which is 0.026. And then, right, I'm also going to be thinking about my max, which would be the 4.001 plus 2 standard deviations away from my mean. So plus 2 times 0.026. When I multiply that, right, my min is going to be 3.949, and my max would be 4.053. So, right, this is my 95% confidence interval. I go back, right? I'm looking at my mean weight. Well, my mean weight, is it inside this interval? No, it's actually outside, right? So would this be unusual? Yes, right? And the reason why is because and I mean, there's a lot of words here, right? So I'm just going to say it, but you want to make sure, right, you could say yes, because I'm thinking about the 95% confidence interval. And what is it, right? That mean weight is outside of it. So just make sure, if you were explaining it, the math way to get those points is to talk about the 95% confidence interval. All right, moving on. This one right here, I mean, this is a 4-point question. I don't know how it's 4 points because I feel like it's easy. Which function has a greater average rate of change on the interval of -1 to +4? Well, whenever I'm thinking right here, right, which one has the greater average rate of change, I want to find the rate of change of m of x, right? And I want to find the rate of change of p of x, right? So if we look at m of x, my rate of change is always going to be my outputs over my inputs. I'm just going to start by just throwing my inputs in right off the bat. So I'm going to say 4 minus -1, right? That's the change in my inputs. Change my outputs. Well, 4 matches up with what number? 81 is my output. And then -1 matches up with +1. So when I do the math here, I get 80, right? 2 negatives become a positive, so 80 over 5. Or my rate of change over here is going to be 16. So now, right, first part done. Rate of change for m of x. You already got a point, right? Now I go to my second function, right? And here I'm going to say, well, now I have to actually put my input in to my function to get an output. So let me start with my first one. I'm going to say p of -1 equals 3 to the power -1, which is really just 1/3 plus 1. So when my input is -1, what's my output? It's roughly, right, 1.33 repeating, right? Let me do it again. P to the power 4, or sorry, P of 4 says I'm saying 3 to the power of 4 plus 1. So P of 4, right? If I give an input of 4, what's my output? My output is 81 plus 1, 82. And I'm going to do the same thing I did over here, right? Change my output. So 82 minus 1.33 all over 4 minus -1. What does that give me? Gives me like something like 80.67. Right now, right, already we can see, well, 80.67 divided by 5, right? Same numbers. We know this one's going to be slightly bigger. It will be 16, I'm just going to say 16.1. But now that you found the two average rates of change, you actually have to create a sentence, right? And I'm just going to say, right, to make it easy, because this little stylus thing doesn't really work the best for me, right? I'm going to say P of X is greater than what? M of X. And the reason being is because, well, 16.1 is greater than 16. And if you did something like that, or if you wrote a sentence, the average rate of change of P of X is greater than M of X because 16.1 is greater than 16. That works. All right, moving on. Next one I like, because I feel like we never really did anything like this in class where we had to sketch the function, right? So first thing, well, I want to find my zeros of this function. Well, this looks like, right, one with 4 terms. That means I want to factor by grouping. So I'm going to take my first 2 terms. What's my GCF here? X squared. What's left over? X plus 2. And then right now I kind of know, right, what's my hint? I'm hoping that I'm getting something X plus 2, right, as my like second like leftovers. Well, what can I take out to get X plus 2? I can take out a minus 16, right? Because minus 16 times X is negative 16X. Minus 16 times positive 2 is negative 32. Now, right, I bring down my X plus 2s. They stay together. And then I'm going to say X squared minus 16. All right. You would get a point if you got to this point where you factor, right? But you want to actually find, and this is the important part, you want to find the zeros. It's not telling you to factor, it's telling you to find the zeros. So I would have to set these two equal to 0, or no, this is the difference of perfect squares. I'm just going to set both equal to 0, right? I'm going to say X squared minus 16 equals 0, X plus 2 equals 0. So that over here, if I subtract 2 on both sides, that X equals negative 2. Over here, if I add 16, take the square root, I'm going to get X equals not just positive 4, but also negative 4. So I have 3 zeros. Now I want to go and I want to sketch this graph. The biggest thing is here, right, I actually just put this entire function, right, into my graph, and I got what the graph should look like. And then you just want to make sure, the only thing that you have to make sure you plot correctly are your zeros. So if I know I'm going to go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, I know my first 0 has to be at 1, 2, 3, negative 4. Second 0 is at negative 2. And my last 0 is going to be a positive 4. So 1, 2, 3, 4. All right. And then from here, right, like technically the y-intercept's negative 32. You could label that, but if you don't label it, I looked, you actually would get full credit. And you want to make sure, right, if I graph this on my graphing calculator, I'll see, right, that the graph starts, right, in like the negative, goes up, nice little curve, goes to my second 0, nice little curve, and finishes off going into positive infinity. If you draw something like this, you're getting like basically 2 points for the finding the zeros, and then 2 points for sketching the graph. Right? I don't think this is that bad. Last one, little word problem, right? You got the function, this is the 2-pointer. D of t equals 2 cosine of pi over 6t plus 5. It models the water depth in feet at a location in a bay, t hours since the last high tide. Describe the minimum water depth of the location and justify your answer, right? So whenever I'm looking, right, trig function, I feel like I've said this a couple times in the videos, my 3 important things. I know my 2 is my amplitude, pi over 6, right? I would even just highlight it, right? 2 is my amplitude, pi over 6 is my frequency, and then my midline, right, is 5. Well, if I'm trying to find my min and max, I need to do or take only 2 of these things, right? I'm taking my midline, right? So I'm going to write that out. My midline is what? 5. And my amplitude is 2, right? In order to get my min max, what am I doing? I'm taking my midline and I'm adding 2 to get my max, subtracting 2 to get my min. So if I just show, right, 5 minus 2, 3 feet is the minimum. And you're good to go, right? When it says justify, right, you got to make sure you show something that tells them that you knew how you got that 3 feet. All right. Short answer part 3 in the books.